Hey there, everybody. DevBiker here. And as promised, I'm back to play a little bit more with this iCUE link adapter and get an idea of what we can do with it. What I'm going to be doing today is taking a look at how Corsair and iCUE manages the power budget for this device. We're going to be connecting, of course, this Aurora strips to it. And if you were with me for the initial unboxing and initial impressions video, you'll remember that I was pretty surprised at how conservative Corsair was with the power budget and how little power these things actually pulled. So we're going to be digging a bit more into that. We're not only going to be looking at the Aurora strips, but we've also got some original Corsair strips as well from years and years ago. We've got some Amazon cheap strips. You can just go to Amazon and buy, hundreds of them. I've also got a bunch of different fans that we can connect to there. Really, I want to get a look at, again, how Corsair is managing that power budget and what that means from a brightness perspective, and as well as what is safe to actually put onto these devices without necessarily blowing it out. Because my assumption, at least right now, without having taken one of these apart yet, is that we have a fuse in there, just like we had on the Lighting Node Pro. And that if you put too much on there, you'll blow the fuse, which is a safety feature, believe it or not, kiddos. So you don't want to be doing that because that fuse is there for a good reason. That said, a bit of warning and a disclaimer. What you are about to see here is not supported, not recommended by Corsair. If you do this, you will probably be voiding your warranty. I am probably voiding my warranty. After watching this, I doubt Corsair support will actually honor an RMA for these devices. So better me than you. We'll see what we can do with these. Now, if you happen to be from Corsair support and you are watching this, please take this as your trigger warning. What you are about to see is not safe for your work environment, so proceed at your own risk. With that, and without any further ado, let's go ahead and get into messing with these devices and seeing what our power draw looks like. All right, so let's get started by establishing a baseline. We're going to use a single 430 millimeter Aurora strip as our baseline. Take a look at how much current it draws at full white based on how we have it configured in iCUE. So we will see that with nothing configured, just connected, we're pulling about we're pulling about 0.01 amps. So really negligible, not much at all. Let's go ahead and add a strip on there. So we'll see that we're now pulling about 0.03. This is going to be for the 3 red LEDs. But as we go into the lighting effects and we set this to full white, you'll see that we are now drawing 0.71 amps. So really not very much power is being drawn by this. Hardly anything, really. So let's see what happens, though, as we come into our lighting setup and we add additional strips. So if I go ahead and add a second 430 millimeter strip, we'll see that we have the brightness reduced warning. So this is telling us that iCUE is going to reduce the brightness by changing the RGB values that it sends. Come into our lighting effects, and we will again set it to a static color. And you'll see that we are now drawing, instead of about 0.7 amps, we're now drawing about 0.57. So a little bit less, about 0.1 amp or so, and a little bit of change less is what we're drawing right now than when we had it configured as a single. Go into our lighting setup and just add some more strips on here. Let's add 3. Take a look. With 3, we're down to 0.3 amps. So if we actually had 3 strips on here with all of these LEDs, that would be 49, 98, 146 LEDs. We would be pulling about 1 amp. A little less than 1 amp, 0.9. Let's do one more. Come into the 430 millimeter. Let's all This is all four of these. We're now down to drawing 0.15 amps. It is noticeably dimmer. And if we had all four of the actual strips on here, we'd be looking at a total draw of about 0.6 amps, maybe a little bit more. So we can see that this is very, very conservative from a power budget. But what I'd like to do is take and see what these values look like for other. I'm going to come back into my lighting setup, turn all of these off. That way we have nothing happening, no power being drawn. Corsair support, close your eyes, don't watch this. Take this, get this out of the way. And we've got some of the original Corsair strips here. Now I've got 6 strips on here. So we will only expect 5 of them to light up. And on the 5th one, we'll have an additional LED that's not going to be lit up because it's only going to light up 49 LEDs, even though we have 60 of them. This, we see our red. Our red is now pulling 0.08 amps, so almost 0.1 amp. Take a look at our lighting effects. And when we set these lighting effects to full white, we can see that we are actually pulling significantly more power, actually a full amp more than what we were pulling with the Aurora strip. So what this is telling me is it sounds like Corsair is adjusting the power budget, not based on the power draw of the Aurora strip, but actually based on the power draw of a typical LED. Let's actually confirm that. Let's turn this off. And what I'm going to do now is connect some super cheap strips that I got off of Amazon. I soldered on a connector for the Corsair, right? And there's 60 of them on here too. So let's go ahead and set that static color. There we go. And you'll see that this is drawing about 1.6 amps. So pretty close to what the Corsair strips were drawing. Corsair strips may be drawing a little bit more because those things are several years old. So that could have something to do with the LED age. These are pretty new. I just got them just a month or 2 ago. So that could be a reason for the difference. It could be that these are just a little bit more efficient because they're more recent. But what it does look like is Corsair is actually using the typical power draw from a typical WS2812B LED to calculate what the max power draw is that it's going to allow on this link adapter when it goes into power saving. Let's do a little bit more. Let's see what happens and what the power draw looks like with these. Actually, let's go ahead and flip back to the Corsair one. Let's turn this back on. All right, so we can see we're back to 1.7. Turn this off, go to our lighting setup, add double this, back on. There we go. We're at 1.38 amps being pulled. So if we doubled this, we would be at 2.7, a little bit over 2.7 amps. That's actually a bit more than I was expecting it to be. Let's go into our lighting setup. Do 3 of these. Let's go back to our lighting effects. Yeah, we should still be good. We should only have 49. And you'll see now we're down to 0.71. So if we actually had the full number of LEDs on here, we'd be running at about, what, 0.21 amps. Go into our lighting setup and do the 4 effects. And now we are down to about 0.38, 0.4 amps. If we actually had 4 of these on there, we'd be at about 1.6 amps. So it looks like our max usage is right down here when we have 2 strips. because here, if we actually had the LEDs on here to match what we've configured in iCUE, we would be running at about 2.76, 2.3 amp of current being pulled. Let's see what this would look like with the cheap strips off of Amazon. Turn this off. And let's turn our static color back on. And this is about the same, right? We've got about 1.36 amps that are being drawn. So if we actually had all of these on there, we'd be looking at about 2.7 amps. I'm going to have to do that. I'm not ready just yet to blow a fuse in one of these devices, but I will be giving that a shot. I will be putting all of these on there and see if it pulls the full 2.7 amps with this number of LEDs on there. And if we blow a fuse when we do that, because we just might. So we'll have to see about that later when I'm ready to possibly blow a fuse in one of these devices. So next, let's compare what our power usage is between the link adapter and the original classic Lighting Node Pro. So I've got 6 strips on here. When we have these set to full white on the link adapter, we're pulling about 2 amps. So just a hair over 2 amps. So let's go ahead and take this off of here. And then we will connect this to channel 2 on the Lighting Node Pro that I have here. There we go. We'll see that we're pulling 0.05 amps. Let's go to our Lighting Node Pro, our lighting channel 2, to our lighting setup. There we go. We've got 6 RGB strips set on here. Now let's go ahead and turn this on, the full white. And we'll see that we're actually drawing, in this case, only pulling about 1.8 amps. So the Lighting Node Pro is the same number of LEDs. It looks like it is going to adjust the power usage down a little bit lower than what we see with the iCUE link adapter. Again, not something that I expected to see, but kind of interesting to note. It beginning to seem to me that perhaps that fuse and the power budget that they allocate for the link adapter is closer to maybe that full 3 amps that the connector supports. Whereas on the Lighting Node Pro, they tried to keep it under 2 amps, under 2 to 2.5 amps, primarily because that Lighting Node Pro is connected via SATA power, and SATA power is going to be limited to 4.5 amps on the 5-volt rail. Let's go ahead and take this back. Let's take these off of the Lighting Node Pro. Let's put them back onto the link adapter, and let's take this down. You know what? I'm going to disconnect the 6th strip from here as well. So that way we have no more than 50. This will help us compare it with our baseline, those 49 LEDs that we had with the Aurora strip. And take us through and take a look at what our power draw looks like when we change the what we have connected to the strips. Let's start with, you know what, I'm going to do the LLRGB series fans. Now we do see that we have brightness reduced. These have, 16 LEDs. So if we do 3, this will give us 48 LEDs. That's going to be very close to our baseline. And let's take a look at our lighting effects. So we have these set to all white. And you'll notice that these are now drawing about 1.67 amps. See that on the last one. We have all but 2 LEDs lit. So this is 48 LEDs lit at about 1.67 amps. Again, this is interesting because with the LL fans, you're not going to be able to necessarily connect 3 LL fans in line like this. You're going to need an RGB LED fan hub of these things. This is a naked one. If you buy them, they'll have They won't be naked like this. But these have their own power source. So, it really, as long as you actually have it connected to a fan hub, it really isn't going to need to go into low power mode, but it will. So as we go into 4, you can see that hasn't really changed. Let's do 5. Effects haven't really changed. And then we go ahead and we add 6. At 6, we get the brightness reduction. Go into our lighting effects, and we can see that, yes, the brightness is being reduced. We're down to 1.4 amps now, so we can see that iCUE is adjusting that power usage down, and it's doing it on an assumption that you have LEDs directly connected to the link adapter. Let's see what this looks like if we do have actual LL fans and what kind of power draw we're looking at from those LL fans. So we saw what the power usage was like when we had strips connected but configured as LL fans. We saw the power usage drop. Let's see what it looks like when we have real LL fans connected. In this case, these are connected via an RGB fan LED hub, so one of the original hubs. They're not really going to be drawing any power at all from the link adapter. Instead, they are going to be fully powered by the Corsair RGB fan LED hub, which is connected to SATA power. Right now, we have this configured as a single fan. So if we come into the lighting effects and we turn it on, we see that only one of those comes up. And we see that one fan at full white is pulling about 0.5 amps, so about half of an amp. All 6 of these on a single RGB fan LED hub will pull a little bit over 3 amps, which is perfectly fine. We've got 4.5 amps available to us with that fan hub because that's what's available on the SATA power line. So let's see what happens as we add additional fans on here. So if I remember correctly, once we get to 6 fans, there we go. Once we get to 6 fans, we get that brightness reduced warning. Let's see what kind of amperage we're pulling now at white. So we can see that the power usage actually dropped to about 0.4 amps when we have all of these connected. Looking at the LL fans, they do look a little less bright, but it's really not that noticeable. Get down to 5. See that we're back up to 0.5 amps. And the difference in brightness, I don't know if you can see it on the camera or not because this kind of gets washed out. But the difference in brightness, at least from my eyes, is pretty minimal. All right, let's go ahead and take a look at the QL fan. All right, so we're back. We've got real QL fans connected right now to an RGB fan LED hub. This is connected to our link adapter with a fan hub cable, so it's not going to be pulling any power at all from the link adapter. The fan hub is pulling power directly from SATA. So let's go ahead and see what it looks like, how much power an individual fan draws as we configure this with the link adapter. So right now we have it configured as a single fan. We come into our lighting effects. We have it all on white. So single fan at all white is going to be pulling about 0.5 amps. So with 6 fans, this will be 3 amps, which is well within the budget that we have on a Corsair fan RGB LED hub, or a commander core, or a lighting node for that matter, because they're all powered from SATA, and we've got 4.5 amps available to us on that 5-volt rail on our SATA connections. So let's see what happens as we start adding fans and adding LEDs on here. We come to our lighting setup. We add 2 fans. We don't have a brightness warning. And we're seeing that we are still at about 0.5 amps. And here to our light set up. Let's add our third fan. We get our brightness warning. Going to keep on harassing me, right? And now we are down to about 0.4 amp. So we have dropped power usage per fan. Brightness, I don't know, can't really tell the difference. At least not at this point. Let's set it to 4 fans. Come into our lighting effects. With 4 fans, we can see that we're now down to about 0.3 amps per fan. They're starting to get noticeably dimmer. If we come to our lighting setup, let's do 5 fans. Go to our lighting effects. And we are now at 0.2. So again, getting noticeably dimmer. We're continuing to reduce power usage. And we'll come into 6 fans. Go ahead and say OK. So now we are down to 0.11. And at 6 fans, we have 180, 24, so 204 LEDs connected. And so for 34 LEDs, we're drawing 0.11 amps. So for 6 of these, we would be drawing, what is it, about 0.6, 0.7 amps. So significantly less. Let us come in here and you know what? Let's see if I can adjust the brightness. And nope, I cannot. So this brightness is not something that is adjustable. iCUE is doing it. You're not going to be able to override it. Let's see what this LED count does. 99. Somebody needs to go back to kindergarten, because we certainly have more than 99. There's actually no way for the link hub to actually determine how many LEDs are on this. Certainly, it could infer how many LEDs are connected, say by sending a signal, even something small, and measuring the voltage or measuring the current usage, right? As it increases the number of LEDs. There are ways that it could do it, even though the WS2812B protocol doesn't support that directly. But when you have a fan hub in there, there's no way for it to do it. It's got no idea how much power is actually being used by the devices that are connected to it. So this is wrong. A little note on this, because I've played with this quite a bit before I started doing the recording of it. This doesn't work, or at least it doesn't work reliably, or maybe it doesn't work reliably when you're continually connecting and disconnecting devices. How about that? It will probably work just fine for you if you connect it to your system, plug everything in, go ahead and set it up the first time, and then you'll be good. From what I could tell, as best as I could figure, it would do the calculation either on initial device enumeration or on iCUE startup. I actually did have it accurately count how many LEDs were on there. This 99 is 5 strips plus 1 LS430 strip, and it accurately got 99. Before that, I had 1 LS strip on there. It accurately picked up 49. Since then, however, it has refused, no matter what I do, to actually update the count. So I'm not exactly sure why that is. It could be that it just updated that count on initial device connection. And maybe because it's seen the device on here, it's not going to update the count. I'm not entirely certain. But take a look at that. It actually does not adjust the count every time you click the button. It just shows you what it thinks is connected. So it's not something that I would rely on for the actual count of LEDs that are on. So let's also see, right? Let's take a look at what kind of power usage we're going to have with if we connect this to the old school Lighting Node Pro. Right, we'll start with 1 and go to our channel. Let's turn it on as all white. And you'll see that we're drawing 0.49, so 0.5 amps is exactly what we would expect. And the same thing that we saw with the link adapter. Let's go ahead and see what happens when we configure this for all 6 fans. So we have 6 fans on here. Let's go back. Ooh, boy. Yeah, this is noticeably brighter. This is significantly brighter than it was when I had this configured for the on the link adapter. And you'll see that we're still running at 0.49 amps. So these are still getting full power, which again is fine. They're being powered from the fan hub. So there's no power being drawn from the lighting node Pro. There's no danger of it blowing a fuse out. And it doesn't bother to reduce the dimness. So let's go ahead and let's take these off and we'll see what it does with the 8 LED fan. All right, so we have the strips connected back again, and we've got it configured for the 8 LED series fans. Now, the most we can put onto a single channel is going to be 6 fans. That's going to give us 48 LEDs. I'm not expecting that we will see a brightness warning here when we go into the lighting setup. So let's go into the lighting setup. We'll set this for 6 fans. Sure enough, we don't get any sort of brightness warning. Would not be expected. Come into our lighting effects. Let's go ahead and turn on the all white. And you'll see that we're running at about 1.67 amps. So this is pretty much in line with what we saw when we had 49 LEDs on there at 1.7 amps. This only has 48, so it's just a little bit less. But we're not seeing any brightness reduction. We're not seeing any power reduction or anything like that when we have configured as 8 LED fans. Let's go ahead and actually attach 8 LED fans and see how much power draw we have from each one of those fans as well. All right, we've got our 6 8 LED fans connected. They're connected to a fan hub, of course. And the fan hub is connected to the link adapter. Let's go ahead and see what kind of power usage we have with this. All white. There we go. And so here we have 0.28, so about 0.29, 0.3 amps per fan. So for 6 of these, we're still looking at, what is that going to be, about 1.8 amps. So under 2 amps being pulled for the 48 LEDs. Pretty much in line with what we would expect to see. All right, so the last thing I want to do today is I want to see if the power limitations are by individual iCUE link adapter. Certainly, the message that we're given by iCUE would seem to indicate that it is by individual iCUE link. But let's go ahead and see if we can confirm that. So I've got 2 link adapters now connected to my link hub. They're both connected to the same channel. They're actually in line, one right next to the other. So I'm going to go ahead and configure this. One of these as 430 millimeter strip. Okay, so that's this one. This is not what I have the multimeter connected to. So let's keep that as it is. So we've got one 430 millimeter strip on there. Let's come to the other one. See, that went to all white. Let's go ahead and configure this the same way as one 430 millimeter strip. There we go. Now notice that we did not get a reduced brightness power warning in this scenario. If we had 2 430 millimeter strips on the same iCUE link adapter, we would get that brightness reduction message. So let's see if brightness is actually being reduced or not. Let's go into our lighting effects. And we can see that we are pulling the full 1.7 amps. So we can see that brightness is not being reduced, at least on at least in this configuration. So let's go back to our other link adapter, so the one that we don't have the multimeter on. And let's go ahead and set this to two 430 millimeter strips. There we go. Now we do get the brightness reduced. And again, the brightness reduced is telling us that it's due to the iCUE link adapter power limitation. We can see that our other link adapter is still going at full white, and it's still pulling 1.7 amps. So we have not actually changed the power usage on the link adapter that we only have configured for a strip. So that confirms that the power limitation and the brightness reduction is actually done by individual link adapter. It's not done for the channel on the link hub. Now, how this fits in with the multi-device power limitations when you're running over 7 devices on a single channel with iCUE is a little bit uncertain right now. I don't have enough spare fans to actually simulate that and see what it would do. But I suspect that your link adapter is going to count as a single device when you are doing that. So you could put, say, 2 link adapters in and then 5 fans to get to your 7 device limit before you start seeing the power limitation brought in by iCUE for the number of devices on a single channel. How that will play with the power limitation for the individual link hub, I would suspect that those limitations are additive. But that'll be an experiment that we have to do for another time. Maybe when I get more fans and actually see what happens. All right, let's talk about some of the things that we learned in our various experiments today. Number one, kind of the key takeaway is these Aurora strips are incredibly efficient. The power draw is very, very low compared to what we see with the original Corsair strips, off-the-shelf Amazon strips, or really anything else. Number two, Corsair is managing the power budget, it appears, based on an assumption that you have standard WS2812B off-the-shelf generic LEDs actually connected. So could they make the Aurora strips brighter, be a little less aggressive with the reduction in power with the strips? Probably. But I think they're doing it in order to ensure or to help minimize the number of issues that they have, RMAs and that kind of stuff, because of people overloading the power capacity of link adapter. Because there's nothing stopping you from connecting, say, almost 200 standard off-the-shelf El Cheapo Amazon LEDs and telling iCUE that you have the super efficient Aurora strips, in which case you could very easily blow out the fuse that I am assuming is inside that link adapter. But I can understand why they would be that conservative with that power budget. That said, there are some implications for that, particularly if you want to control fans with and have them connected to an RGB fan LED hub. With the 8 LED fans, not a problem. You won't even notice it. There's not going to be any brightness reduction. You've only got 48 LEDs on there. It's going to be fine. With the LL fans, up to 5 LL fans, which is going to be 80 LEDs, is going to be fine. You won't get any brightness reduction. With that 6th fan, however, you will start to get a brightness reduction. That said, it's not that big a deal. It's not that noticeable. But we could measure it, and we could actually see that reduction happen. The QL fans, on the other hand, after 3 fans, that brightness reduction starts to get pretty significant. Even when they're being powered from the Corsair RGB fan LED hub, they reduce in brightness quite a bit, and that is going to be a potential issue. In fact, by the time you add 6 LED fans on there, it's pretty dim and really not that good of an experience. Well, thanks for joining me. That's all I have for now. I'll be back in a bit with some more stuff on the link adapter, as well as the entirety of the Corsair link ecosystem and Corsair cases, all that kind of fun stuff. So then, catch you later.